Welcome to all. I think this is lecture number 5. Anyway, I won't tell because you can see title. Today we will discuss centroid, that is G, for a triangle. I won't explain what is triangle all because this is not a geometry class. This is structural class. Okay. Now, before you start, one basic definition. I won't write every time. Let B be the base and H be the height. Note, everybody should know area of triangle equal to half into base into height. Either you can tell half into base into height or half into height into base, or some people write base into height divided by 2 because base into height will give area of a rectangle. Triangle is half of that one, BH by 2, but we will always use half into base into height. Now, very, very important class, something I am telling now. So many people, they got confusion about regarding centroid for triangle and also later for moment of inertia. For that, you should remember one important point. What all I tell now, correctly understand. See, H is height, is perpendicular to base. Very important. When you tell height H, it should be perpendicular to base or normal to base. Never use the word horizontal vertical. You never by heart, horizontal is base, vertical is height, problem will come. You never by heart that way. Height is perpendicular to base. If the base is horizontal, height is vertical, or if the base is vertical, height is horizontal. So here, height means not usually see in common language, height is for vertical. No, here, height means with respect to base. So I will tell you now, see, suppose there is a triangle here. Make a note. If this is the base, see, base, horizontal, perpendicular, this will become height. General triangle. Or suppose you mark a triangle this way and then you call this is the base B, then this will become height. See, with respect to base, height is you remember throughout our structural engineering and especially centroid and moment of inertia, you remember height is perpendicular to base. Now, once again class, the triangle, there are 3 cases. One, triangle in general means no restriction, simply base and height. Then isosceles triangle. It is a triangle in general where isosceles means what? You can see 2 angles are equal. Which angle is equal I will tell later. Or the vertex, if you draw a perpendicular to base, it will divide into 2 equal parts. Later I will tell you. Lastly, the most important, right angle triangle. This is the most important. Most important. These 3 cases we will discuss. So with all these, I will remove this board now and I will tell what is triangle in general, what is isosceles triangle, and what is not what is. Everybody knows it. The significance or how we will consider here, I will explain now. Okay, I will prepare sketches now to save the time. Start correctly, systematically. You go through the entire class. I will go for derivation today. After the triangles are over, 3 cases, I will consider trapezium. Then I will consider semicircle, I don't have to consider, semicircle and quadrant, and if possible, some area bounded by an arc, that also I will consider. That is only from exam point of view. Once all are over, what all I explained here, one class will be a solid summary class. Full class will be standard result in systematic way. How much I explain today, I may explain much more on that day. And from then onwards, I will tell now onwards, if you get confusion or if you don't understand, you are not fit to study from me. You go to a person who teaches better than me or who knows better than me. Okay. Sorry for these words. Okay. Start. I told 3 cases are there. Case 1, triangle in general. See, general means it is my word. Simply triangle, no restriction, simply triangle. No, only base and height are there. See, right here. Triangle in general means base and height, that's all. Only base and height. See, you consider only base and height. Consider just two terms, base and height. There, see, it can be like this or it can be like this. Here, B is the base, H is the height. See, for the base, height is perpendicular. Here, horizontally I am marking base, so vertically, and here I can use it. Vertically, I am marking height. Or I can take vertically base. See, you look this way. This is the base. This will become height. Now, of the point or opposite to base, the last point, see, these are the 2 ends of the base. Triangle, 3 points are there. The point which is opposite side, that is after the height, what you get is vertex. That is what I think in mathematics. I am not bothered much, vertex or vortex or apex, sometimes people call. I will use vertex. See, suppose somebody may tell tomorrow in mathematics, some other meaning is, in my class, that is the meaning. You remember, this is vertex. I think correct it is. So, what you do is, see, this is the base. These are the 2 points of base. From the base, along height, go to the other point, opposite point, that is vertex. Here, this is the base. So, therefore, from the base, along the height, go to opposite point, this is a vertex. Now, here, see, this side, this is the total B. Imagine if I put a dotted light line here, this side distance is B1, that is B2. Here, this is B1, B2. So, your B1 is not equal to B2. B1 is not equal to B2. It can be anything. And also remember, either B1 can be more than B2 or B2 can be more than B1. Never bother. We never consider that here. In the derivation all, we never consider. What to do is, along the base, see, from vertex, if you draw a perpendicular here, the base is split into 2 parts. One side, one part is B1, other is B2. Little later for structural engineering, I call this instead of B, I call loaded length L0. Then I will call this as A and B. That I will explain in structural engineering. Result is same. Instead of B, B1, B2, there I tell L, A and B because it is a very popular, simply supported beam with uniformly varying load this way, one side A, one side B. That all I will see. What you derive here, you can replace the terms. But basically I will tell, see, along the base, 2 parts are B1, B2. Here, any one B1, see, there is no restriction. You can take any one as B1, other B2. There is no rule that B1 should be equal to B2. By chance, your B1 becomes equal to B2, right? Case 2, it becomes isosceles triangle. See here, if it is isosceles triangle, see, you know, I won't explain what is the meaning of isosceles triangle or isosceles triangle also same theory once again. See, if this is the base, this is the height, vertex, or if this is the base, this is the height, vertex. But if you drop a perpendicular here, perpendicular, 2 sides will come, these 2 are equal, only B by 2, B by 2, these are B by 2, B by 2. Or you can write isosceles triangle is also triangle in general, that is your case 1, but B1 equal to B2. See, when B1 becomes equal to B2, both become equal to B by 2. Oh, because this angle will be equal to this angle. These two sides are equal, that we don't require. We want only that what? From vertex, if you drop a perpendicular here, base is divided into two equal parts. This is isosceles triangle. Okay, now, lastly, see, I am giving more importance by changing color. Red I am not giving because red I am using for centroid. So, right angle triangle, this is the most important. Most important. Very, very important. Actually, in structural engineering, 90%, not 90, more than 95% times, you require right angle triangle only. Rarely you require this one and this one. This will come very rarely, but this comes through structural engineering, everywhere it will come. Okay, now, here, what you do is, right here, one note in the class I will tell. Right now, first, don't define base and height. Let the two sides, see, one of them is x0, other is y0. This is actually hypotenuse. See, this is 90. The two sides which meet at the point where angle is 90, that is x0, y0. Here, x0 I am marking horizontal, so x0, not x, because x stands for variable. I don't call, see, still I have not used base and height. If this is x0, this is y0. Okay, leave it. You write here, horizontally x0, vertically y0. See, of course, this can be like this also, or it can be like this also. That all we will discuss later. Important is what you never by heart 90 on the right side, nothing like that. Two sides which are perpendicular to each other are x0, y0. This is your hypotenuse. Now, right now, I will do one thing. In the class, the one I am marking horizontally, I will call x0. Vertically, I am marking y0. Now, here, among x0 and y0, any one can be base, other can be height. Remember, other can be height. See, any one can, among x0, y0, any one can be considered as base, then the other will become height. Any one can be considered as base, that is considered as base means what? B, then other will become height H. But make a note here, this is not valid for these two, because if this is the base, this is the height. This is not the base. See here, this is not the base. It is this way. So this special provision or right here, this special provision or extra liberty is not there for triangle in general and also for isosceles triangle. Of course, for that one, it will come only if you divide this triangle into two triangles. Okay, see, suppose for some reason you draw a vertical line and separate the two triangles, or here, draw a vertical line, separate the two triangles, then it will become two right angle triangle. That is special case later. Therefore, this liberty of calling any one as base, other height, is not there for triangle in general or isosceles triangle. In triangle, in case of triangle in general or isosceles triangle, there is just one base and one height. See, base this way, height this way, or base this way, height this way, base this way, height this way, base this way, height this way. But here, see here, what happens is, you can take x0 as the base. See, you write here, one case, you take x0 as the base. If you take x0 as the base, then y0 becomes height. Y, see here, perpendicular. Oh, the diagram is interchanged there. Oh, I should change it. Okay, done. See here. You can take x0 as the base, then y0 becomes height. Or, see, or I change it. I should have marked the same way. I turn the sketch. Okay. No problem. See. This is your x naught. This is your y naught. Now see, when you take x naught as the base, y naught becomes height. So opposite to base, this will become your vertex. Whereas you can take y naught as the base, no problem. If you take y naught as the base, then your x naught will become height. Then this will become your vertex. I will explain more later. So remember, see, I will tell once again here, see, if you take x naught as the base, y naught is the height, this will become vertex. If you take y naught as the base, x naught becomes height, because height is perpendicular to base, then this will become vertex. You understand all these. When I go to summary later, I will explain much more. But at that time, I will write formula here. See, centroid is somewhere here. This is h by 3, 1 by 3. This is 2 by 3. This distance is b plus b1 by 3. This is b plus b2 by 3. Here, this centroid distance is 1/3 h, 2/3 h. From here, b plus b1 by 3, b plus b2 by 3. I will tell here 1/3 of h, but this way midpoint, this way 1/3 of h, from there 2/3 of h, this way midpoint. Here I will tell this way 1/3 x naught, this way 2/3 x naught, this way 1/3 y naught, that way 2/3 y naught. 1/3, 2/3 will come only when height is defined. So it will come, I will tell it later, when height is defined, that 1/3, 2/3 will come. If height is not defined, then I told some formula for you. See, b plus b1 by 3, etc. I will explain that one. So remember all these. Now I will start first triangle in general. I will locate centroid for a triangle in general. Start now. Case 1, centroid G for a triangle in general. I told general means let B be the base and H be the height as shown in figure. Okay, as shown below. I will take this B and this H. Later remember, see, I will explain. Now note, first we will locate centroid G along the height. See, the derivation is for centroid G along the height. Along the height means measured from either from base, distance measured from base or vertex. See, that is, if this is the centroid, I don't know, I will tell you later why it came there. Then this distance is along the height measured from the base. This distance, the question mark, this question mark, I'll put question mark here, otherwise confusion, okay. This question mark means this is from the base measured along the height, where is centroid. Of course, you will get 1/3 of h later. Or, once this is 1/3 of h, this is 2/3 understood. Or, see, little problem here, ship projection is not correct, okay. Or, distance of centroid, see here, this is as per this sketch, y bar. Why y bar? I told vertical distance we call y bar, okay. Y bar from base. And if you do this way, it is once again distance of centroid along the height measured from vertex. Once again y bar, this is y bar from base, that is y bar from vertex. We will do this case. This we will do. We will derive expression for y bar for this case. Now make a note. If this is the case, suppose this is the base, this is the height, then I told we are locating CG or finding the distance of CG along the height measured from base or vertex. So here this is the height. So we will measure either from here or from here. If you measure from here, it is from the base. If you measure from here, it is from the vertex. Now this will become X bar, not Y bar. Actually, how I prove here, same way proof. Same way prove. Word by word same. You try if you want this one. Actually, there is limit. If I try, see, I will do one thing. I will get to Y bar here 2 times. Once from the base. I will get this Y bar 1/3 of H. Then automatically, this will become 2/3 of H. And then I will do one thing. I will again do one thing. I will prove from that side 2/3 of H. Then this is 1/3 of H. Suppose this total is, say for example, just to understand, write a note. Suppose this total is 90. Easy. If you derive from here, you will get a 30, 1/3. Then automatically 90 minus 30 is 60. Or if you do from top vertex, you will get 60. 90 minus 60 is 30. Both the proofs are not required. I will go for both the proofs. You select whichever you want. Whichever you want to select. Okay. Now this we will do. This is ditto. Turn it. You turn the what you write. See this sketch. Take a paper. Turn it. Then write everything same. Everything. Suppose only thing is here Y bar. There you have write X bar. Here what? Elemental thickness is dy. Their elemental thickness will become dx. This I told yesterday, last class. Not last class. I think last class I told, when you want to Y bar, Y variation, thickness of strip, elemental strip will be dy. When you go for X variation, thickness of elemental strip will be dx. Okay, now I will go for this one. Okay. Right now, I am not pausing. See, one small information I will give you. Not a big information. See, there are so many derivations in structural engineering. Engineering, mechanics, strength of materials, structural analysis, RCC, steel, or pre-stress concrete, matrix method, finite element method. So many things are there. In my entire teaching, I never bother about proof. Any proof of any subject you want any time, I can do it. Why? Because not by hurting. It is called confidence. I never bother how to prove. It is, I can see in front of me. Everything I can see. See means what? By the inner mind. By hurting, but you should practice and reach the same stage. It is possible, not difficult. That is, everything you should understand. That is the main problem nowadays. Okay, now start. See now, I will tell you once again, no. See, start. Now start the derivation. Right, start the derivation. This is the triangle. Random triangle. See, A, I will tell B, and C. This is vertex. This is the base. See, I am not putting B1, B2. This is the height. Anywhere you can mark, this is the height. What you do is, this is here, consider elemental strip. Remember, before that, remember, make a note. See, we want centroid here. This is G. We want from base. This is Y bar. So, to get Y bar from base, I already told, from base measured along height. What you do is, see, consider elemental strip of, I won't use color now, of thickness dx. This is mathematical dx at very important, sorry, not dx. When you want Y bar, elemental thickness is dy. dy at Y from base. Why base? Because we want to measure from base, y from base, as shown, see here. This is the base B, this is the height h. We want to y bar, so you take a strip, elemental strip of thickness dy at what distance? Y from here, up to where, no problem, or this is y. Okay, to make it more clear, I will use color. Okay, this is dy, this is y, right now. This is your elemental strip, see, strip. And this width, let it be b dash. And for this one, area equal to dA, elemental area dA. So right here, let dA be area of elemental strip. Then, see, after all this, then y bar from base, y bar from base AB, from A here, B here, AB equal to, I told yesterday, integration of dA into y divided by integration of, divided by area, okay, divided by total area, A. And for information, area is integration of only dA, okay, elemental area, dA, okay. To make more clear, dA, right, color, dA. Now, limit required, see, you should understand, one more class I will upload later regarding limit. Now you understand, you are measuring y from here up to here, see, 0 to h. Limit of integration is 0 to h. This also 0 to h, limit, 0 to h. See, your y will start from, see, strip. If the strip is here, 0. As the strip keeps on going that side, your y will increase. Your y, see, you are measuring y like this. From here to here is the triangle. So, y varies from 0 to h. That much common sense required. Now, first what you do is, I told you one note. See, I write a note here. I rub it out now. Note. First get b dash. I written b dash there. No, not written. I write here. One more thing. See, let one more thing. Let b dash be width of the strip. Width of, see, here also dA green color, elemental strip, dy also green color, y also green color. Okay. Let b dash be width of elemental strip. Elemental strip. First get b dash. B dash. How? Use similar triangles. See here. Be careful. Similar triangles, you should stand here where 0 is there. See, b dash divided by this distance. Be very careful, not y. If this is y, light line, you write here, light line. This is h minus y, very light line, just only for understanding purpose. Actually, not required. When this is h, this is y, anybody studying high school will tell it is h minus y. Okay, now b dash divided by h minus y divided by h minus y equal to b divided by h. If this is not clear, you cannot study structural engineering. Okay, or I write here your b dash, green color. Okay, this is green color. Your b dash will be, see, b and h are constants. B by h into h minus y. H minus y. Okay, done. Now write. Therefore, dA, I told what is dA. dA is area of elemental strip. dA is b dash into dy. It is b dash into dy equal to b by h into h minus y. This is the b dash into dy. Into dy. Therefore, your numerator, that is integration of 0 to h of dA into y will become integration 0 to h of b by h into h minus y dy. H minus y is green color. Okay, h actually not required. Okay, leave it. H minus y into dy into what? Into y. Into y, or equal to b by h, you can take outside, common, integration 0 to h of b by h outside, h into y into dA, it is what? H into y minus y into y is y square times dy. Okay, now leave the color. Why bother about color? dy equal, now I stop the color, equal to b by h of h constant, h into y becomes y square by 2. I should not tell all these things. Y square by 2 from 0 to h. Then space problem here, minus y square becomes y cube by 3 again from 0 to h, or equal to b by h of h into y square by 2. 0 to y is, y square is bracket h square by 2 minus 0, lower limit, minus y is h cube by 3 minus 0, or equal to, see here, equal to b by h into h. Anything problem? B by h into h is there. So b by h into h cancels, h square, h cancels, bh square. If you take outside, see, bh square, h cancels, into 1 by 2 minus b by h into h cube. See here, h and h will cancel. Something wrong here? Something wrong. H into h, got it. B by h into h cube by 3. So this h and h square, see, b by h into h cube is bh square into 1 by 3. This is not clear, means don't study math, study structure engineering, or equal to bh square. See how slowly I am doing, into 1 by 2 minus 1 by 3. I don't think calculator required, is 1 by 6. It is 1 by 6. 1 by 6. This is the numerator. Okay, now come to denominator. See, denominator is A, that is area of the triangle. Area of the triangle equal to, now, integration of dA from 0 to h. Actually, it is a waste of time right here. Waste of time because everybody knows that, see right here, everybody knows that area of the triangle is half into base into height. You can directly use. Still for your information, I will do it here. See, equal to integration 0 to h of only dA. Only dA means what? B by h into b by h into h minus y, actually waste of time, into dy. Now you try it. See now, correctly. I won't waste time. B by h, no space, that's why I am writing here now. See, space is not there. See now, that is equal to b by h times h into dy is h into constant is y minus y becomes y square by 2. Y square by 2, 0 to h, or it is b by h into once again h minus h square by 2. H square minus h square by 2 is h square by 2 equal to, see, equal to b by h of h square minus h square by 2 is h square by 2 equal to bh by 2. Yes, bh by 2. But actually remember, not required, just I shown you. Just for information, you can do one thing. Don't waste time. You do one thing. Denominator is area of the triangle. Basic formula is integration of dA. If a curved area is, if the area is bounded by a curve, last time see, then you have to integrate. But for a triangle, throughout the world, even primary school students, they know that area of triangle is half base into height. Therefore, don't waste time all these. You directly write area equal to directly half into base into height. Therefore, your y bar equal to, see, last answer now. Therefore, you get y bar measured from base equal to, where is the formula? Integration of dA into y by area equal to integration of dA into y is, where is it? bh square by 6 divided by area is bh by 2, or equal to bb cancels, h square by h is h, 6, 12 will go to something wrong. Yeah, not 12, it is 2. I was wondering how 12 came. Okay. 2. I got a shock of my life. Why? 12 by 6 becomes 2. Okay. 2 will go to numerator. 2 by 6 is 1 by 3. If this you cannot simplify, I should tell why you are attending the class. Equal to h by 3 is the answer. That is y bar. So, right here. Therefore, lastly, make a note. This y bar equal to h by 3. Write one answer. See, therefore, answer. You write here. Answer is, put the sketch once again. Write y bar equal to h by 3. Then write, if this is h by 3, here only, this distance from vertex will be h minus h by 3 equal to 2h by 3. You make a note there. Okay. This is one answer I got. I got y bar from base. Now do one thing. To correctly understand, I will go for, now everything you copy. Once you copy, you write the sketch once again. Okay, right here. Alternate solution. See, write the sketch. G, we will find this y bar. See, y bar from, see, you draw a reference line here. From there, you get y bar. You take this as y bar. That is to get y bar from vertex. vertex. Okay, start once again. Consider elemental strip of thickness dy at y from not base, y from vertex. Vertex is C. Let dA be the area of the strip. Let B dash all remain same. The only change now is, now this is your y. See, your y is here. Y is here. Now, therefore, then first get B dash similar triangles. Now see, it becomes little easier for you now. See what happens now? Directly, B dash divided by y, B dash divided by y equal to full is base divided by height. So see, compared to last time, little easier. Therefore, your B dash equal to, now it will become more easier. Your B dash will become B by h into y. Last time it came B by h into h minus y, so little better. So your numerator, that is integration of, again limit is 0 to h only, y starts from here, y comes here, again 0 to h. Numerator, that is 0 to h of dA into y will now become integration 0 to h of, I not forgotten. Okay. Therefore, area of elemental strip, I forgot, elemental strip, that is called dA equal to B dash into dy. See here, B dash into dy, that will become equal to B by h into y into dy. Okay, now, therefore, I rub it here. Your numerator, that is integration 0 to h of dA into y will now become integration 0 to h of dA is B by h into y into dA, this is dA into y, into what? Into y, or equal to B by h times integration of B by h common outside, integration 0 to h of y into y is y square dy, or equal to B by h of y square becomes y cube by 3, 0 to h, or equal to B by h into y cube, means h cube by 3 minus lower limit is 0, or equal to bh cube by h, bh square by 3. That is numerator. And denominator, that is area, is integration of dA, or no problem, directly you can write, not required, for a triangle, area is half into base into height. Direct answer. Therefore, here I forgot right here. See, that formula I forgot. You should write. I forgot change it here. See, here I wrote y bar from base. I wrote earlier integration 0 to h. Y bar is red color. Okay. Y bar is red color. Y bar from base I wrote 0 to h of dA into y by integration 0 to h of divided by area I wrote. Area, that is integration of dA from 0 to h I wrote. Do one thing, I forgot to change it. When I do second time, I forgot it. You write y bar from sorry, I forgot it, from vertex C. Vertex C. Make a change. I forgot it. I suddenly saw it there. I rubbed everything. I forgot rub. See, once I tell y bar from vertex, it is from vertex. That much common sense should be there. Don't make an issue of it. I forgot to change the statement there. Okay. Now, denominator is area. Therefore, your y bar from vertex C equal to integration of dA into y by total area equal to, that is, BH square by 3 divided by BH by 2, BB cancels, H square by H is H, 2 will give to numerator equal to 2 by 3 of H. Now do one thing. Come back here and write y bar equal to, you write here, final answer. Final answer is, this is 2 by 3 of H. Then write, if you got 2 by 3H from there, from here to here, this distance from base will be total is H. It is H minus 2H by 3. 2H by 3 equal to 1 by 3H. H over. Okay, now make a final note. I am closing now. This portion I am closing now. Final note you write now. All removed. Anything by chance if I forgot to change, you don't make an issue of that one, you change it. See, sometimes what happens is, when I repeat some calculation, suddenly something, see, formula remains same. Only thing is, it was earlier y bar from base. Now I am changing to y bar from vertex. Therefore, everywhere I change it, but one place I did not change it because I overlooked it. Such overlook is, it is a usual human nature. Now see, now write today's class answer, final conclusion. See, I am telling conclusion now. Okay, I won't clean too much because why? Because this is going to come once again later. Okay, sufficient. Note now, therefore, result. Final result. Okay. I thought I will do that along base today. No, today I will stop here because tomorrow I will conclude because little more discussions are there. Otherwise, it will become lengthy class. See, case 1. Triangle in general. Triangle in general. These are all very important. See, this is the base. If you call base, this is the base B. Base B. See, there is no rule that these are equal. Anyone can be, okay, little bigger I put, because I put earlier, little bigger here, okay. Not that I will discuss tomorrow. Which is bigger does not matter. That matters when you locate CG along the base. When you locate along the height, it is height H. This is height H. Base B, this is height H. Now, note, centroid G measured along height, that is y bar. Here y bar, not y bar, along height, that is somewhere along height, that is distance. See, along the height means distance either from base or vertex. Here. Centroid is here. I have marked little this side because I know that if this is smaller, this bigger, it will come tomorrow. Tomorrow you will be knowing why I shifted side. This shifting we are not bothered. We are only bothered about this distance. See, this distance and this distance. If you measure from base, it is 1 by 3h from base, whereas if you measure from vertex, this is the base, this is the vertex, no ABC now, vertex. It is 2 by 3 of h from vertex. Same way, similarly, by chance you consider a triangle this way, make a note. If you consider a triangle this way, anyone bigger, anyone smaller, no problem. Now, similarly, if we consider a triangle this way, if this is the base B, this will become the height. We will measure, once again same, here also measured along the height, here also measured along the height. Here actually, remember, along the height, here it is, here y bar, here x bar. Measured along the height, see, centroid will be somewhere here. This is the base, this is the vertex. From the base along the height, if you measure, see, this distance will be 1/3 of h. This is x bar. If that is 1/3 of x from here, from the vertex, this will be 2/3 of x. Sorry, what x? 2/3 of h. Sometimes I'm feeling little tired. I have taken marathon class in the afternoon. Now it is nearing midnight, 2 o'clock. Therefore, little feeling tired. Suddenly, such things you don't bother. This is your centroid G. Tomorrow's class, I will explain how to see, this is over, how to locate the CG along the base. What is this distance? What is this distance? Or what is this distance? What is this distance? Little work is there. I can do either by integration or by summation principle. Divide this triangle into 2 right angle triangles. I will decide tomorrow. Shall I go for integration? Very, very lengthy it will become. But guaranteed answer will come. Or you can use this result and get the answer. I will decide tomorrow. Okay, now thoroughly go through everything I told today. Understand, make a note. So today's title is Centroid for a Triangle Part 1. Tomorrow will be Centroid for a Triangle Part 2 and also most probably centroid for trapezium. Suppose I feel time problem tomorrow, suppose after I explain each and everything, if it takes more than half an hour or 40 minutes, I will do part 3, that is for trapezium. Because trapezium, what you are doing is, you are dividing it into rectangle and triangle. That we will discuss later. Once triangle trapeziums are over, then I will go for circle not required, center is centroid, semicircle and quadrant, and even I will consider, see, semicircle, quadrant, even. On some partial area, only some arc length considered here. This actually you require only for some special subject, but I may do it, may not do it, or I may, okay, I will decide. Okay, anyway, most probably I will do it, no problem. See, this one you have 2 options, either by considering strips like this or by using radial distances. Everything I will explain for this one. That is next class, not next class, after trapezium. So tomorrow will be part centroid for a triangle, part 2, concluding part of triangle. If time permits, tomorrow only trapezium. I will write and trapezium, or I will do centroid for trapezium, separate class. Depends upon time only. Okay, thank you. Study thoroughly. I am telling every class, study thoroughly. How much thorough you are studying, I don't know.